Number 1 is 48, and number 2 is 100,000. All right, now we're going to talk about a permutation. You guys want to go ahead and write down this introduction to, and that's not a grammatical thing. That's a math symbol today. It's an exclamation mark, but in math we call it a factorial. Okay, so that's what it is. Go ahead and write that down. All right. So let's go ahead and talk about this. Just a moment. When you use the fundamental counting principle to determine the number of possible orders or arrangements, it's called a permutation. So when you lose an option every time like that, because you're putting things in order, that's called a permutation. Go ahead and write down number 1, please. All right, well, there's 5 people in your family that are lining up to take a group picture. How many different ways can they line up? So we're going to approach this with the same exact thinking as we did with the last problems. We need somebody to take the far left, and then somebody needs to stand next to that person. And then after that, another person. Then after that, another person. And then the last person. They need to stand up in some kind of order from left to right so that everybody can be seen in the picture. All right, now we're going to keep it easy. Obviously, there's different family arrangements. You got some people sitting in the front in a smaller row or something. But we're going to keep it easy, just left to right, in a straight line. So, well, here's where we're going to get started with somewhat of the new thing. How many people can stand in the first spot here on the left? I see you guys said 1, and you're right. Only 1 person can stand there. But so let me rephrase that. How many different people can stand here? It could be any one of 5 people. Now, after somebody stood there, what's left for the next choice? There's only 4 people left for the next spot. 3, 2, 1. And so we're just going to multiply straight across, and that's a permutation, okay? So 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. There is a slight difference here on number 2, so let's read it and see what that is. It says there are 10 people racing in a race. How many different outcomes of the race are possible for first place, second, and third place? Now, here's the deal. I need to make 3 choices. Who comes in first, second, and then third? Now, how many outcomes are possible for first place? 10 different people could end up being first, because there's 10 people in this race. It could be any one of the 10 people, right? Now, after one person is taken first, they can't also take second, right? So how many options are left for second place? And then 8. Now, here's the difference here. You guys see, it doesn't go all the way down to 1 like the first problem did, because I'm not including everybody in this race. If I said, how many different ways can these people all run across a finish line? Well, then we go all the way down to 1. I don't care about that, though. We're asking first, second, and third only. There's a limit placed here. We're only going to third place. So this would be 720 possible outcomes for the race. Here we go. If there are 20 people in a class and Mr. Bailey is selecting 2 students at random to go do a problem on the board, how many different orders can the students be called in? Well, I have 2 choices to make. Who I'm going to call first and who I'm going to call next. Now, the first choice can happen in any one of 20 ways. I could pick anybody out of the 20 kids in class. After that, there's 19 kids left to choose from. And that makes 380. Now, I worded this very carefully. I worded that in how many different orders can I call those students up in. So like, for example, suppose I called Javier and Alexis up here to do a problem. That counts as one way. Alexis first and then Javier. And another way would be Javier and then Alexis, right? But does that really matter who I call it first? Next class we're going to talk about how to get rid of the order because we don't care about the order. So this one has order in it. In other words, I'm treating Javier and Alexis like is different from Alexis and Javier. Next class we're going to talk about how to fix that so that it's really the same event, because it really is. All right, so let's have you guys go ahead and practice some of this. Kevin, what's number 1?
5,000 weights.
And number 2?